Okay, I think we're going. I hope this works. I'm using Cami, so I don't know if this is going to be quite great. We'll see. All right. So I promised to make a video about matrices super fast. We certainly don't have to go way into in depth and do all of these examples. Just get the gist in order to be ready for the ACT exam. Okay, so you got a smattering of matrices, which is just a general array. Oh my gosh, I hope this works. I'm not used to this program. I actually had to turn in my computer because Video is destroying my ability to do simple tasks. So hopefully I can do this. Is this drawing? Let's see. So this matrix has 3 rows. Yay, it works. And 2 columns. That's how you name matrices, first of all, rows by columns, by their dimensions. We're going to make this pink, hot pink here. All right, so this is 2 rows by 4 columns. I mean, be careful, I'm moving. I don't have much space up here. So 2 is 2 rows by 4 columns, and so on and so on and so forth. This is also 3 by 2, 2 by 2 by 2 by 2, and then same thing, 2 by 4. So what are the dimensions? Oh, I'm a maroon. It's right here. So the dimensions of A are 3 by 2. Make sure I got this right. B is 2 rows by 4 columns, so we can do that. And then C is 2 by 2. Good thing they don't keep asking that. We get the idea, get the gist. Now, adding matrices is the most Mickey Mouse operation ever. First of all, the only way you can add matrices if their dimensions are spot on. Meaning, if I add these matrices to add A plus C, I add the elements together in each equal position. That's in row 1. Column 1, add 6 and negative 3.2. Row 1, column 2, add the negative 1 and the 1. And so on and so on and so forth. In the last position there, row 3, column, you'd add 2 and negative 7. So I don't think I have to show the rest. Add, and then the answer would still be 3 by 2. D minus B, would we even be able to do that? Sure. And I'm just going to reference it. We're not going to write it because I'm crunched for time. This is the second time I've tried to make this video. Video keeps killing me. I told you that. All right. So D minus B, you take 13 minus 14, and then you'd get negative 1 in that position. Then you take 1 minus 3 and get negative 2 in that position. Number, doing all of those processes. A plus F. Here we go. We got some problems, just like Mr. Samuelis. All right, you have a 3 by 2 and a 2 by 2. So who doesn't have any friends to add with? Like Mr. Samuelis has no friends. You don't have any row 3 numbers. So this would be called not possible, no solution. Your calculator would say dimension mismatch, so on and so forth. You just say not possible for that. Right? And let's move on. What's 2D? 2D is just called a scalar multiple. 2D would just be 2 times this matrix, and actually you just distribute the 2 and multiply every component of this matrix by that. By the way, I just remembered on the video Friday that got destroyed. I mentioned that, right? Video. Was talking about what is a matrix anyway, and it's kind of sad that we don't teach it as much anymore because I bet you people that might be computer engineers, matrices are used quite a bit. And what these rows and numbers usually apply to, like for a business, some actual data from the business. And that's why when you see matrix multiplication, which is really wild, what happens with it, kind of crazy. But there's a reason for it. And that's not what's important for the ACT right now. Anyway, 4E plus A. Well, 4E plus A means you'd have to do your scalar multiple on E first, and then add those components to A. And that would be a dimension good dimensions because these are both 3 by 2s. So you'd have to quadruple these and then add the quadruple of that to 6. Add the quadruple, that'd be negative 16 plus 3. You get it. It's easy. And now would we be able to do 3F minus 2C? Let's look at that. 3F, sure we would. 3F would be 3 times F minus 2 times C. I think this one I did do on the video Friday, so I took some time on it. Here's 3F. Let's make it quick. Negative 45. So 3F. 12. 3 times 22 is 66. I hope I'm getting these right. 3 times 0 is 3. Kidding. Minus 2C. You know what I would do on this? Well, you know what? We'll double C. 2 times C is 0. 2 times negative 3 is negative 6. 2 times negative 7 is negative 14. And 2 times 5 is 10. I'm really worried that this video is even going to work. And if it doesn't, you won't even know. So why am I even talking about this? Because then the video won't exist, and then you won't be watching this. But notice what I did with that minus sign is I distributed the negative, and then you go ahead and add these components that are in each position. 12 plus 6, 66 plus 14, 0 plus negative 10. Going fast. Hopefully I'm not screwing up. All right, and now for matrix multiplication. All right, let's write this down before we fill in the words. I always have troubles with the words. Let's change the green just to mix it up a little bit. All right, so this is 3 rows by 2 columns. I don't know if I like that color. Purple. Oh, that's pretty. All right, and then this is 2 by 2. Okay, you can only remember this is rows by columns. Rows by columns. Okay, I got it. You can only multiply matrices when the number of columns in the first matrix, you'll see why in a minute, equal the number of rows in the second matrix. Order matters. So what are the dimensions of A? I keep doing this. It's 3 by 2. I wrote it over here. Dimensions of B is 2 by 2. So can I multiply A by B according to these rules? Yes, because these are both equal. The columns of the first equal the rows of the second. I'll show you why when we get to actually doing it. All right, what you're going to find out is the dimensions are this. And when I actually do it, you'll see why. So I can, and those are the dimensions of the answer, these outer dimensions. 3 rows by 2 columns will the answer be? That's how Yoda would say it. But then when I do B times A, B is a 2 by 2 times A, which is a 3 by 2. You're going to find out that these don't match, which is a dimension mismatch for matrix multiplication. Now, this is the kind of ACT question I've already seen. It was a question about 3 matrices and can I? Can I multiply this times this? Can I multiply this times that? Switching them around, so on and so on and so forth. I can. Lock ports. And then that means the dimensions are going to be 4 by 3. You'll see why. I cannot. So this is a dimension mismatch, which would be no answer. Dimension mismatch. I don't have the time to write all the words. Leave me alone. And then this is a no. Oh, wait. GF. Can I do GF? No way. But can I do FG? FG would be a 2 by 3. F times G, a 3 by 1. That's a yes. And weirdly, the answer would only be a 2 by 1 matrix when you're done. How does this all work? You'll find out. So here's a good one. First one, A times B. I'm not rewriting them. I'm using these all up here, and I might erase. What? All right, and this is a 2 by 2. Still nervous that this isn't going to work. Wrong. This is a 2 by 3. The dimensions match that I've associated that needs to be done. And then the answer is going to be weirdly a 2 by 3. This is why. Here is the operation. Now just imagine you're working for a company and this row means something. So that row means like 2 different, let's say you have 2 different stores, and then this is store 1. And then this is this column, this matrix, this column means how much money you make off each. I don't know. I can't think of a good example. But this is what you do. You take the rows of the first and multiply them by the columns of the second. That's why these numbers must match. Because I have 2 numbers here, 2, and 2 numbers here, 2. So I have a dimension match. I have the same amount of numbers in the rows of the first and the columns of the second. And then this is physically what you do. You take the first number times the first number plus the second number times the second number. And then this number goes in the first row, first column, first row, first column. And then you move along and you take the first row and multiply it by the second column. Now we can do the multiplying. 7 times 1, 7, plus -2 times 5, -10. And then you take the first row and multiply it by the third column. 7 times 2 is 14. -2 times -2 is 4. And then you add those numbers. So this would be, I don't know, a big number. -3 and then 18. Those would be good. And then who didn't play? The second row with each of the columns. 4 times 6 is 24, plus 3 times 1 is 3. 4 times 1 is 4, plus 3 times 5 is 15. 4 times 2 is 8. 3 times -2 is -6. And then you'd add these two: 19, 27, number, -3, 18. Oh, what a mouthful. All right, C times B. Can I? C times B. Let's write the dimensions. 3 by 2. Oh, this is going to be a mess. And then B is a 2 by 3. Not only can I, this is going to be nasty. I'm going to have a 3 by 3 left over. Here's why. Where's the eraser? Well, the thing that says eraser. Nice. Okay, and then where's the drawer? There it is. We still purple? Great. So what I'd have to do, I don't want to rewrite this, but imagine this is in front of this. So I have to take the first matrix, C, its rows, times B's columns. We got a match there. So I do have 9 times 6, which is 54, plus, I'm not doing this whole thing, 6 times 1 is 6. Then you take this row times this column. So imagine C is over here. Sorry for shorting you on time here. I'm in crucial mode of getting this thing completed. 30. And then that first row times that third column. 9 times 2 is 18. And then 6 times -2 is -12. And then same thing you would add. And then you do the same thing with the next row. This row times these 3 columns, sum. And then this row times these 3 columns, sum. Now, that's not going to happen on the ACT. They're not going to ask you to get this full product. They're just going to get through, can you multiply? Or if they'd multiply, it'd be like a 2 by 2 times a 2 by 2 maximum. All right, let's talk about one that does not work so you know why. And then when you know the why, you have a better chance of memorizing. If you know the process simply of multiplication, then you'll know when things don't work. Let's see, B times C would work. Here's why B times C would work, because B is a 2 by 3, and then C is a 3 by 2. But really, it's because of this. And it would, you know what? I should look at this. This just stopped working. Technology. Oh my gosh. Am I too high up there? Maybe I am. All right. Here's what it would be. Maybe I'll start it off. How this works then: B times C, rows of the first times columns of the second. B rows, C columns. 6 times 9 is 54, plus 1 times 8 is 8, plus 2 times -1 is -2, and you did get one number out of that. And then you take this row times this column, number plus number plus number. Then you take this row times this column, number plus number plus number. I just don't feel like doing it right now. And then you add them. And then this last one, second row times second column, number plus number plus number. And you end up with a 4 by 4 matrix. Very easy. Let's get one that doesn't work. EA works because I have, this is simply a 1 by 2, and this is a 2 by 2. So you take this row times this column, this row times this column, and get a 1 by 2. Where's AI? AI, it's going to kill us. You know what? I do like AI, because I do get worried that they might ask you a question about what's called identity matrix. And it is interesting that they did name this I on this worksheet that we used. I is the identity matrix. Very convenient that we use the letter I to explain it. Why it's called the identity matrix, watch what happens. And I did do this on the video that didn't work on Friday. And then 1001. Actually, identity matrices have to be square, and the ones have to be in this diagonal all the way down. I'm just worried that that might come up. So when I take this row times this column, it's 7 times 1, which is 7, plus negative 2 times 0, which is 0. 7 plus 0 is 7. Then when I take this row times this column, that's 0 plus negative 2, which is negative 2. And then when I take this row times this column, 4 times 1 is 4, plus 0, which is 4. And then when I take this row times this column, it's 0 plus 3 times 1, 3, which is 3. So why is this called the identity matrix? Because when I multiply an identity matrix by another matrix, it becomes the matrix that we originally had. It doesn't change the matrix, it stays the same. And then let's do F times B. Oh, here we go. And then maybe this will solidify why matrix multiplication can or cannot work. Sorry again, I don't feel like rewriting this, but when I do F times B, F, I choose the rows times the columns. Wah, wah, wah. 1, just like Mr. Samuelis, has no friends to multiply with, to play with here. So this is called a dimension mismatch. And we could see that in the dimensions. F is a 3 by 3, and B is a 2 by 3. When these numbers don't match, it's not possible to multiply. So there's another dimension mismatch, no solution. No answer, whatever you want to say, not possible, whatever. Okay, and I think that really does the trick there. Again, this is way beyond what the ACT will do. They will never have you multiply and end up with a 3 by 3 matrix. They just want to know, can you, in a lot of cases. All right, hopefully that helps.